Okay, muting everyone. Okay,
Okay.
mute all. Yes. Okay, so we just stopped in the isotherm process of isotherm. Now we're going to adiabatic changes. So adiabatic change, what is adiabatic change or process? So adiabatic change is actually we have a state of gas that no heat enters or leave the system. So if you can imagine, there will be one. Who's chatting there? Who 147? Okay, okay. Where's the pen? Okay, adversity change is a change where the state of gas that occurs and no heat enters or leaves the system. So if we have a container, okay, when we have a piston, so the gas over inside, okay, we compress or expand. Therefore, we no heat coming out or no heat coming in. Yeah, Nikki, why are you doing that? Okay, heat out and heat in. So this is we call as adiabatic change. Okay, you compress and expand the gas without any changes, any heat coming out. It will be a perfect insulator of the container. One example is when we have a bottle over here. Okay, this is a bottle is compressed. Uh, the gas, uh, partially gas inside the bottle is compressed. When it pop on the bottle of champagne, the pasteurized gas inside the bottle expand rapidly. So the work of the outside air, the W work is bigger than zero, means that it doing the work, the gas is doing the work. So there is little time for the gases to exchange it with its surrounding. So we can say that Q equals to zero. So the expansion is nearly adiabatic. Okay, Q equals zero, hence the internal energy of the expanding gas decreases. So U, change of U equals to negative W, and is lesser than zero, and the temperature drops. So actually what you can see here, the temperature is drops. Okay, this makes water vapor condense and form a miniature cloud. So you can see that there is a miniature cloud surrounding the opening mouth of the bottle. So this is one example of the uh, of adiabatic process. Okay, so the way we do is we can prevent the heat by surrounding the system with thermally insulating material. It's a zero Q in and zero Q in going out, or by carrying off the process so quickly. Also, one more way, another method, there is not enough time to appreciate the applicable the heat flow. So change of Q equals to zero. No heat in, no heat out. So we have learned there are so many process. Recall back. You can see that this one is called isobaric. Who knows what is isobaric? Who knows it's isobaric?
The
Let me
pressure is it?
pressure constant.
Okay.
Pressure constant. So you can see that this line over here, we have a constant pressure. P constant. Okay, P constant. So say he mute on, then what else? You can unmute. First time using Zoom.
That's why you don't know what.
Yeah, you don't know. Okay, so
Wait, where's Jeremy? No need lah, Jeremy 100 lah.
okay,
Hi, Jeremy. Poor guy.
so isobaric, and this one we call as isothermal. Isothermal means that isothermal means what is called as isothermal process.
Undergoes a change of state at constant temperature.
Constant temperature, correct? Okay, so the curve over here we have a a line where the temperature is equal or same. Okay, so isothermal where you can see that this is the curve of isothermal from A to 4. Meanwhile, adiabatic does not goes into the zone. It can be changed from, you can see from A, it can be to change the temperature to other side. Okay, you can change the temperature from one temperature to one temperature. It can be increased or can be decreased. Okay, and isochloric is where we have isochloric where we have a V constant. The volume is constant. Okay, throughout the process. So you can see there are three processes we have to remember. Okay, isobaric, constant pressure, isothermal, constant temperature, and isochloric, constant volume, and adiabatic will be the will is a process where Q in and Q out will be zero. Okay, so the first law of thermodynamics, if we recall, okay, Q, the heat going in or heat going out, equals to change of internal energy
Mm,
energy of gas plus with the W, the work done. It can be positive or negative. Since Q equals to 0, okay, no heat in or no heat out, this one will be 0. So the change of U, okay, will be negative of inversely of the work done. Okay, so if U is positive, work done will be negative. If U is change of U negative, work done will be positive. Okay. This work done is by the gas, it's not by the system. Okay, so during adiabatic expansion, W will be positive and U will be change of U will be negative. Okay, decrease in internal energy implies a part of energy is used to do external work. The temperature of gas molecule decreases. It's easy if I draw like this. Okay, we have a container, we have a piston over here. Okay, and we have a lot of molecules inside the container. Okay, so because it has a lot of space, Brownian, we call a Brownian motion, we have a lot of space. Okay, so the temperature, okay, the temperature kinetic energy will be lesser. Kinetic energy K, kinetic energy EK, kinetic energy will be lesser. Okay, because it has a lot of space to move. And okay, one more, if we compress, okay, we may compress the container, okay, compress the gas actually, compress the gas, the EK, the EK will be increased because of we call KE will increase because there are no room for the uh no room for the gas to, I mean actually there will be more collision actually, because the lesser room there will be more collision than before, so EK will be increased. So you can see that if I do, this is W for the gas. W for the gas will be positive or negative. This one. Who knows?
pol
Positive or negative
neg
for the gas?
pol negative is that? Wait, compression
Hmm.
positive.
Positive, that is correct. W for the gas will be a positive. So change of U will be a negative. Because you see a temperature decreases. Right. So you change of U will be negative. At this side, okay, W for the gas will be, work for the gas will be
Negative.
negative. Okay, so change of U will be positive. So this is why the temperature goes up. So you can see the relation between them, work and internal energy of the gas. Okay, very easy to remember which one is positive, which one is negative. Okay, we go to the next part. Okay, in a practice, in order for the adiabatic process to be carried out, the process is carried out very quickly, so the heat flows slowly, has no time to flow. Flow, um, flow, right? Okay, or in out. Okay, rapid value of changes. There is no time to heat transfer. The gas inside we have to get a very perfect insulator cylinder. Okay, there's a law to get rules to get a adiabatic change. Okay, when the gas is compressed adiabatically, so the V change of V, okay, is decreasing. The increase of pressure is greater. Of course, when you compress, pressure will be increasing. It's greater than produced by similar isothermal compression because, okay, the value of pressure, okay, P by adiabatic, okay, P by adiabatic, P by adiabatic, pressure by adiabatic is bigger than P by isothermal. Okay, the value of is because increase of temperature causes the kinetic energy of the gas molecule to increase. Okay, you can see this equation. Okay, increasement. See, this is pressure is the uh number of moles. Is it number of moles divided by the volume of the gas times the mass. Okay, so you can see that increase the density n over m over v of the gas and the kinetic energy increases the pressure further. So that's why we have a bigger compression of the adiabatic changes. Okay, so example of adiabatic change. One is a diesel engine. Okay, the rapid increase in the temperature ignites the air fuel mixture spontaneously. So what's the difference between diesel engine and petrol engine? Who knows? Diesel engine and petrol engine. The difference between them. You can see on the animation there. The big difference between diesel and petrol engine. What's the difference?
Wait, pastor say something.
Hmm? No, no, sir. Who
Don't know
knows?
lah.
What's the difference?
So, pastor, don't know.
Diesel power trucks.
Yeah, of
Funny lah
course.
dia.
No shit lah.
Hmm.
Wait, you want to say something, right?
Alright lah. Correct.
The difference
At least he
is
said something.
the big difference is over this one, this part. What should be there? What should be there?
Don't know.
Ah,
Piston lah.
piston. Wait,
Igniter. Is it?
piston is this thing we call a piston, the upper one on the above. What should be there?
Some torch. Fire.
Fire,
Igniter. Is it?
ignition actually. This engine does not have a spark plug.
Oh.
Okay,
Yeah,
doesn't
that.
have any
Yeah.
spark plug. Okay,
Oh yeah, that thing, sir.
yeah, that thing.
That's right.
Okay, this engine does not have a spark plug. It's only rely on the compression to make the fuel burn or combustion. Okay, in your car you have a spark plug. The spark plug does the one who make a combustion happen. This is the difference between diesel engine and uh, conventional engine. But this process is adiabatic. It means that there is such of insulation that the Q cannot go out or Q cannot goes in. That is the big difference between diesel and petrol. One more is adiabatic change is the propagation of sound wave in the air. Sound wave is actually uh, sound wave is what kind of wave? What kind of wave is it?
With a
Hmm.
Mechanical wave.
What type of wave is sound wave?
Transverse?
Longitudinal wave.
It's a
converse.
longitudinal.
Oh, yeah.
Oh no.
Forgot already.
Longitudinal wave.
Ah.
Okay. Why call as longitudinal wave? What is the meaning of longitudinal wave?
It's got
Quite
a
Particle
contraction and refraction. It does not, the way of propagation is not perpendicular, but is parallel to the direction.
parallel. Okay. Particle are parallel to the
It's
propagation of
correct.
the wave. Okay. So one of the example of adiabatic change is propagation of the sound wave in the air. Okay. The second one. Wait. Okay. So there's a reflection and compression. Okay. One more example is how does temperature of air decreases. So you can see temperature of the air decreases as the altitude increase. We call as there are two types of wet adiabatic and dry adiabatic. Okay, we are not going to discuss this in the deeper level, but we know that when the air goes up, okay, by 1 kilometer, okay, the temperature will be decreased by 10 Celsius. Okay, 1 kilometer goes up, it will be decreased by 10 Celsius. It's because when as the air parcel of the air is pushed upward, it moves into a region of lower pressure. So high pressure above is low pressure. High pressure, low pressure. Okay. So it expand and does work on its surrounding. So when it goes up, it will be expand. So this one will be small, this one will be bigger. As it does, volume is increased, so the temperature goes down. Okay, and the drop in the internal energy leads to decrease of temperature of the air. So you can see that when you goes up uh, in the high latitudes, okay, the temperature will be drops down linearly. Okay. Okay, next part. Okay. Uh, Adiabatic equation you have to derive. Okay. By yourself is inside. I think inside the objective of this.
Yeah, inside the textbook.
Yeah, inside the textbook.
What
It's
page,
you have to derive by yourself. Okay, inside the textbook, and you have to memorize it. Okay. So what it came out is end of derivation. It will be very long actually. Okay. So end of derivation is pressure times the volume times the gamma. What is the gamma actually? Remember what is gamma? Gamma is
Hulk.
what? C PM divided by
Plus CVM.
CVM. Or one more, gamma equals to
The degree of what's that?
degree of
F
freedom
minus
min-
F minus 2
minus or plus? Plus 2
minus or plus
divided
over
by
over
What?
FF.
about the F. So you have to include the gamma here. Both of them are using gamma. Pressure times the volume times with the power of gamma equal to constant means that P1 V1 gamma equals to P2 V2 gamma. Is what we call as constant. Before and after will be equal. One more is TV. TV temperature 1, volume 1, gamma minus 1 equals to T2 the second temperature after after a process, V2 gamma minus 1. Okay, remember this is only for diabatic process. It cannot be used for others. Okay, so either you want to use TV or you want to use PV. Okay,
Okay, sir.
so let's say we have here, actually this is gamma. Sample of gas with gamma 1.4 is at atmospheric pressure and the 300 Kelvin is compressed adiabatically. Very good. You see the keyword, adiabatically, compressed adiabatically to 1/3 of its volume, 1/3 of its volume. Find the final pressure and temperature. So final pressure and temperature. So what we have here, we have gamma equals to 1.4. Atmospheric pressure, how much can? Atmospheric pressure,
The atmospheric pressure is 101 K.
0.01. Okay,
101 K or
10
101,325 PA.
101
1325 PA.
to 3
325.
325.
325
325
PA. Pascal.
Pascal.
325
Okay,
Pascal.
okay. Uh, to 1/3 is volume. So actually P1 over P2 equals to this is 1 over
103.
113. Yeah. Okay. Find its final
I don't know
pressure
why
and
that one.
temperature. Okay. So we can use PV gamma equals to P1 V1 gamma equals to P2 V2 gamma. Okay. So we have P1. We want to find which one? Pressure P2, right? Okay, P1 V1 over V2 gamma equals to V2 gamma, right? P2 V1. No, it's P2. P2 gamma and P1. There you have it. Okay, not going to do this one. Okay, we came up with the solution there. P1 V1 gamma and then P2 equals to P1 V1 over 2. Oh yeah, the gamma goes down over here. Yeah. So power of gamma. Okay. So 3 over 1, 1 over 1.4. Then you have 4.6 as this is the pressure, pressure after it. And we can use a ideal gas equation P1 V1 over T1, and then you can get T2 equals to 5.06 506 Kelvin for the second temperature. Okay. Any question? Any
No
question?
question, sir.
No question this moment.
Okay. Next part, a helium gas volume of 500 centimeter cube at pressure of 1.0 times 10 power 5. This is actually power 5 PA, and temperature of 300 Kelvin is compressed adiabatically again to half of its original volume. Determine a new pressure and new temperature of the gas. New pressure, number 1. New temperature of the gas, T2 of the gas.
The volume here should be converted to meter cube, right?
Yeah, meter cube.
Because the unit for pressure is in PA, that means the volume should be in meter cube.
Meter cube. Oh, okay, meeting will end in 10 minutes. Okay. Actually this is second last. Okay. Remaining time 9 minutes. How much 500? So 500 times 10 power negative 6, right? Centimeter.
Yeah.
10 power negative
Yeah.
2 times 10 power negative 2 and times 10 power negative 2. There you have negative 6. Okay. And pressure is PA. Temperature drop. This is T1. Okay. New pressure and new temperature of the gas. So this is a working. Okay. P1 V1 gamma. P2 V2 gamma. And then if you do it. Oh, forgot. 1.67. How you get 1.67? How to get 1.67? How much degree of freedom? Helium is which kind?
Monoatomic.
Monoatomic. Diatomic or monoatomic?
Helium.
Helium.
He what monoatomic mono.
Mono. It's
Mono.
mono. So monoatomic temperature 300K. 300K. What kind of range is that? Low, medium, high temperature.
Low.
Still low, right? Still low temperature. So F
Because it's
will be how much is F? 3 or 5? This is 1, 2, 3. How much F is it? It's it's
3. It should be 3.
Should be
3
3.
because X, Y, Z.
There's
Here
no
got X, Y, and Z.
So 3 plus 2 divided by 2, then you have 1.67. Is it? 5 divided by 2.
Should be divided by 3.
Oh,
3
sorry.
plus 2 over 3.
Divided by 3. So 5 over 3, then you have 1.67. So this is 1.67 you put inside. Okay, 1.7. The previous question is it gave you the gamma. This one you have to calculate the gamma by yourself. So you have a P2 equals to 2.67 times 10 power 5 Pascal. And also you can use back the TV gamma minus 1. Okay, TV gamma minus 1 and TV2 by 1. There you have 3.96 Kelvin for the answer for the second temperature. Okay. Oh, finished already. Okay, so exactly 40 minutes for the lesson. We put some of the exercise on Google Classroom. Okay, and I hope you finish all the exercise. I think I will put around 5 or 6 questions. You doing? I think I put ABCD, right? It's easier. ABCD. You pick one, and then you directly get the how much your marks in the Google Classroom. Okay. So see you tomorrow.
Wow,
Okay,
sir.
sure.
It's been very good.
Right. Okay. Bye bye.
Sir,
Yeah.
wait. Sir, you free as well.
No. Another class. I have another class.
It's okay.
Hmm.
It's okay. Next time.
Okay.